In this video, we will talk about congruence classes. So I want to motivate this with an example. Let's look at the integers mod 4. So here I have a list of just some of the integers, but of course they continue on in both directions forever. So, when I think about integers mod 4, that means, well, what are the possible remainders I get when I divide by 4? Well, one possible remainder is I could have 0 as the remainder. So that happens with the integer 0 and 4 and 8, and also in the negative direction, like -4 and -8 further down the road, all the multiples of 4. So all of these green highlighted numbers here, they are all congruent to 0 mod 4, which means that when I divide them by 4, they have this remainder 0. So all of these green numbers, they all have the same remainder as each other when divided by 4. Okay, so all these green ones, let me just list them. So these are like -8 and -4 and 0 and 4 and 8. And of course, comma, ... they keep going. Okay. Well, we also have integers that are have a remainder of 1 when you divide them by 4, like 1 and 5. I would also have 9 if I went further down the road. If I went in the negative direction, I'd have like -3. Right? Notice to get from one to the other, I'm going over in increments of 4. Okay, so these blue numbers, they all have the same remainder as one another when divided by 4. They are all congruent to 1 mod 4. So these are numbers like 1 and 5 and 9, comma, ... And then also like -3 and -7. Okay. We have 2 more groups. All right, so the next group is we have things where the remainder is 2, like 2 and 6. The next one would have been 10 in this direction. If I went in the negative direction, I'd have like -2. All right, so these orange numbers, well, they all have the same remainder as one another, and their remainder is 2. So these orange ones were like numbers like -6 and -2. I could keep going this way. And then +2 and +6 and so on. All right, so we got one more group, which is, well, what if the remainder, let's pick a new color. What if the remainder was 3? So numbers like 3 and 7. The next one would have been 11 this way. In the negative direction, I'd have -1 and so on. Okay, so those pink numbers are all congruent to one another. They all have the same remainder as one another. And that remainder ends up being 3. Okay, so these are numbers like 3 and 7. In the negative direction, like -1 and then -5. Okay, so what we've done now is we've created these 4 subsets of the integers. And these are called the congruence classes modulo, oh, whoops, typo here. This should say module and then O here. These are the congruence classes modulo 4. So in general, if I was dividing by an integer m, so if I was looking at the remainder mod m, remainder divided by m, we could classify these integers into m subsets. Because the remainder, if I was dividing by m, could be, well, it could be 0 or 1 or 2 or anything up until m minus 1. That would be the biggest possible remainder. And now a bit of notation. We call this set of possible remainders Zm. Okay. So let's look at a quick example, and then I'll talk about big picture. Why is this useful? Let n be an integer. If I was looking at mod 2, there are just 2 possibilities for what the remainder could be. Either the remainder could be 0 or it could be 1. So n is going to be either congruent to 0 mod 2 or it's congruent to 1 mod 2, and those are the only 2 distinct possibilities. One of the takeaways from this is using these modular equivalence classes can make doing casework in proofs much quicker. And in the next video, we will take a look at an example where we use this.